Before we can actually tackle this work problem, I have to review a little bit of stuff because this was dealt with in Chapter 1. So the first thing I want to talk about is, let's just make a for instance over here on the side. Let's say it takes Joe um, 15 hours by himself to finish this painting job. So if he works for 3 hours, how much of the job does Joe finish? Well, he finishes 3 hours out of the 15, so that would be 3/15ths of the job. So the bottom, the denominator number for Joe is how long it takes him to finish the job by himself. The numerator number is how long did Joe work on painting this house. And we're going to have these fractions for Joe and Jennifer. So let's skip to the second line here. Working together, they can finish painting the house in 15 hours. So Joe and Jennifer are only going to work 15 hours. Not by themselves, like this example here, but together. So that number is going to end up in the numerators. So let's set up a Joe, Jennifer. And we know what the numerator is going to be. They can finish painting the house in 15 hours. So this will be 15. This will be 15. We're going to add them together, and they're going to finish a job. Well, how many jobs? Well, just one job, painting a house. All right, so the trick is now the denominator. Joe can paint a house 2 hours faster than Jennifer. So if we let x equal Jennifer, the number of hours Jennifer would take to paint the house, that would go here, then Joe can finish it 2 hours quicker. So over here, we have to make sure the time is 2 hours faster than Jen. So if it takes Jen 30 hours to finish the job by herself, then it's only going to take Joe 28 hours, 2 hours less. So this x is going to have to lose 2. So we get this setup where Joe's completion rate of the house is going to be 15 out of x minus 2. Jennifer's is going to be 15 out of x. And when you add these two together, it has to equal finishing painting the one house. All right, to solve this, we're going to have to multiply by the common denominator, which is x and x minus 2. And when we do that, on the first fraction, the x minus 2's are going to cancel, and you're going to be left with x times 15. We'll come back to that. On the second one, the x's are going to cancel, and we're going to be left with 15 times x minus 2. And then over here, you're just going to get x minus 2. All right, so the first one is 15x. The second one is 15 times x minus 2. And the last one is going to be x squared minus 2x after you distribute the x through. Over here, you're going to get a 15x plus another 15x for a grand total of 30x. And then here, you're going to get negative 30 is equal to x squared minus 2x. And then this, unlike the previous work problems I've shown, is not linear in nature because it has this x squared term here. So this is quadratic in nature, so it's best to get it equal to 0 and keep the x squared positive. So if we shift things around, we're going to get x squared minus 2x. We would subtract the 30x from both sides, and we would add 30 to both sides to get it on the side of x squared, and what's left on the other side is 0. All right, and then simplify. 32x plus 30. It would be really nice if this was factorable, factors of 30 that add up to 32, but I don't think they exist. So we're going to have to do that with the quadratic formula. Thanks. All right, so I need to solve this. I'll do it both ways. We can do quadratic formula on the calculator and then completing the square. All right, back to a pen. So quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. The numbers might get a little bit big, but thank God for calculators. And we're solving for the variable x, because that's what's in our equation. All right, so this is going to be negative something plus or minus the square root of something squared minus 4 times ac, all divided by 2a. And then go through and plug in our values. So let's see here. B is this negative 32. So we're going to put negative 32 here and here. A is 1. There's just a 1 sitting in front of that x squared. C is the last number, 30. And then A again is just 1. So let's see. This becomes positive 32 plus or minus the square root of, I'll use my calculator for that part, negative 32 all squared. Now be careful, put parentheses in your calculator. Minus 4 times 1 times 30. 904. So this would be 904, which, by the way, doesn't have a perfect square root. 2 times 1 is just 2. Now, if I do 32 minus the square root of 904, 900 is, the square root of 900 would be 30. So I'm worried that this number would be rather large. So I'll do both of them. But sometimes if you know that this number is really big compared to 32, doing the subtraction for a word problem is usually not worth it. So let's see here. 32 plus the square root of 904, 62.1, and then divide that by 2. So one of the answers we're going to get is 31, rounded to the nearest 10. Go back and put in a minus. 32 minus the square root of 904, 1.9, divide by 2, we're down to 0.9667, which is really close to approximately 1 if we round to the nearest 10th even. Okay, so once you get to your answers, it's best to go back and see what the heck's going on. Remember, the answers are 31 and 1, so let me write that in red. 31 and 1. 31 and 1. If the answer is 1, you would have to plug it into this original equation. And the problem with that is that x minus 2 would become 1 minus 2, which is negative. There is no way that Joe could finish the job before he even started. So the answer 1 is going to have to get thrown out. So that leaves 31, which makes a lot more sense, because this is how long it would take Jen to finish the job, and then Joe would finish it 2 hours quicker. So the answer to the question would be Jennifer would take 31 hours, and Joe would take 29 hours, 2 hours less. And that is a quadratic type work problem.